Okay, a rational expression is just simply a fraction. It's a ratio of two polynomials. So in this section, you are going to be asked to do lots of different things. One thing will be just to evaluate. So you might be given something like y cubed over y squared minus 1. And to evaluate this for y equals -2. So all that means is where you see y, you're just simply going to plug in -2. Anytime that I evaluate, because I always worry about exponents, I put it in parentheses, so that's -2 times -2 times -2. And -2 times -2 is +4, and I get my answer. So that's one thing that you'll start with. Next thing will come up will be to simplify. And this is where all your wonderful skills in factoring are going to come in play. But let's say you had something to start that looked like this. And you might say, well, is that the same? Can't you change this direction? So that didn't change the problem, right? And I think that would just, these cancel or reduce to 1. You want to be careful though, versus say x plus 5 over 5 minus, oops, I meant to put a minus on the first one. And x minus 5 over 5 minus x. Now you can't reverse this, right? Because even if you do, it's -x plus 5. But what you could do is you could factor out a -1. And so if I factor out a -1, my x, and I'm even going to change the order here, -x becomes x, my +5 becomes -5. And now I actually can cancel this, and I am just simply left with 1 over -1 or -1. So that one's a little tricky. But then when you get into something like x squared minus 3x plus 2 all over x minus 1, and you're asked to simplify this. I will tell you a math secret, which probably isn't a secret for most of y'all. Anytime you are asked to simplify and then you need to factor, I can guarantee you one of these factors are probably x minus 1, because that's kind of the whole point, is you're going to cancel stuff. But let's say I didn't know that. X squared is going to be x times x. The only way I can get a 2 is a 2 and a 1. The middle is negative. This is positive, so it needs to be a negative, and a negative will make a positive. And see, I told you. And so therefore, our answer is simply x minus 2. All right, then you will move into multiplying rational expressions. And again, this is where multiply. This is where your factoring is going to come into play. So if you're asked to multiply something like x over 9x minus 45 times x squared minus 5x over 2. You never want to just multiply straight across. What you want to do is to see if you can factor anything. And I remember from my multiplication tables that 9 times 5 is 45, so I factored that piece. I can see up here, I could pull an x out and leave me with that. Remember I told you when you factor, I bet something is going to cancel just the way it works. And then this x times that x is x squared. And it looks like I didn't point to my 2, but my 18 at the bottom. And so multiplying, you do multiply straight across, but you always want to see if there is something you can cancel. All right, do you remember when you divided fractions like this? I don't know, 1/7. You remember what you did? I know students have some saying, keep flip. I don't even know what it is anymore. But and you're probably yelling at me if you know it. But basically what you do is you keep the first term alone, you flip the second term, and now you multiply. So you'd have something like that. Well, you do the same thing with these rational expressions, but once again, please always look to see if there is something you can factor to make it a little nicer. So I have 3n squared minus 5n plus 2 divided by 12n squared plus 5n minus 2 all over n squared minus 3n plus 2. All right, so the very first thing that I would do is rewrite my first term because that's my keep. And now I'm going to put a multiplication and I'm going to flip this second expression. And 12n squared plus 5n minus 2. All right, I'm ready to start looking at both of these and seeing if there's something I can factor. This first term, it looks like I could pull out a 3, and that would leave me with 9n squared minus 4. And if you caught it, this is even the difference between two squares, which would be 3n minus 2, 3n plus 2. So that becomes this. I just happened to catch that when I was starting to work this out. And now the denominator, I'm looking right here, is I need to factor that into two binomials. Well, the only way I can get a 3n squared is 3n and n. And I see a positive 2 and a negative 5. Well, if I put a 2 here and a 1 here, I'll have a 2 and a 3. If I add them, negative and a negative will give me a negative 5, and then negative times a negative will give me a positive 2. You gotta get those factoring down, right? I mean, this is factoring. Probably, if you get really good at factoring, will save you a lot of time in algebra class. This n squared, only way to get the 2, only way to get 2 and 1. This is negative, that's positive, so I need a negative times a negative to get a positive. This one can be a little tricky, but if you remember, I said something about I bet something's going to cancel. So you might say, well, why didn't you use 1 and 12? Or why didn't you use 2 and 6? Because I see a 3 up there. So I bet it's going to be this. I don't know that. I'm guessing to factor this. And now from here, I'm going to look at a plus 2 and a negative 1. And before you're going, wait. Okay, 2 times, so I know that works, the negative 2. Can I get this 5 in the middle? It looks like I'm going to have a positive 8 minus 3, and that works. So that definitely works. All right, now from here's the fun part. You get to start canceling things. So that looks like that canceled. Oh, it looks like that even canceled. So it looks like all I have left is 3 times n minus 2 all over 4n minus 1. So as you can see with rational expressions, they're going to take you back to factoring. And I have some other videos, as well, with just more and more examples. Just takes lots of practice, but as you can see, get that factoring down.